Welcome back to the channel. Today we're diving into one of the most important yet misunderstood discussions happening across crypto, cybersecurity, and digital governance. At the center of this conversation is Switzerland's strong warning about cloud reliance, data control, and the legal vulnerabilities that come with centralized digital infrastructure. What makes this topic even more fascinating is how closely these concerns align with the architectural principles of the Internet computer, often referred to as ICP. This is not about hype, price predictions, or speculation. This is about understanding why the structure of digital systems matters more than most people realize. By the end of this video, you'll see exactly why Switzerland's warning is a big deal and why ICP's unique model provides answers traditional systems simply cannot. This video is for informational and educational purposes only. It is not financial advice. Always do your own research and consult a professional before making any investment decisions. For years, governments and large corporations have been facing a single fundamental question: who truly controls the data we generate and rely on every single day? Most people believe that when they store information in the cloud, the data simply stays locked inside some server owned by a company like Amazon, Google, or Microsoft. But the reality is much more complicated. Even when data is stored in servers physically located inside a country, the company operating that cloud service may be legally bound to a different country's laws. A widely referenced example is the U.S. Cloud Act, which allows U.S. authorities to request data from American companies, even when that data is stored in foreign countries under foreign jurisdiction. This means a country can host its data locally, yet still be vulnerable to foreign legal access. Switzerland's warning directly points to this exact problem. They highlighted that true data sovereignty is impossible if the service provider either owns or controls the encryption keys, or if the provider is subject to foreign legal authority. What most people don't know is that nearly all major cloud platforms include some form of administrative access layer for maintenance, management, or operational oversight. These layers do not necessarily allow the company to read your data directly, but they ensure that the provider retains enough control to manage infrastructure. And if that access exists, even in limited form, it creates risk. It introduces legal exposure, cybersecurity threats, and dependence on an entity that can be pressured, hacked, or compromised. This is where digital sovereignty breaks down. Even highly secure systems become vulnerable when privileged access exists anywhere in the chain. Most organizations don't realize how many subcontractors and third-party components are involved in running cloud infrastructure. The deeper you look, the longer the supply chain becomes. Now, blockchain technology was originally seen as the solution to these issues. But here's the truth most people don't talk about. The majority of blockchains don't actually host full applications on the chain. They host small transactional data, but the rest, the front end, the back end services, the storage, and even the APIs, still run on centralized servers like AWS or Google Cloud. This means many decentralized applications are decentralized only at the transaction level, while relying on centralized infrastructure for everything else. This defeats the entire purpose of digital sovereignty. In other words, most blockchains decentralize the ledger, but not the actual application. This is where ICP stands apart. The Internet computer was designed from the ground up to host entire applications, not just transactions, directly on-chain. That means storage, compute, back-end logic, and even the user interface can run entirely within the network itself. No Amazon servers, no external storage buckets, no third-party hosting. Everything runs inside decentralized smart containers called canisters. And because the entire application stack runs on-chain, ICP removes the hidden dependency layers that traditional cloud platforms rely on. There is no long chain of subcontractors, no external indexing services, and no off-chain databases. ICP eliminates the centralization points that regulators like Switzerland are warning about. One of the most crucial components behind this design is chain key cryptography. This system allows the Internet computer to scale globally while still maintaining extremely strict cryptographic guarantees. With chain key cryptography, node operators never see or control private keys. The network itself manages key rotation cryptographically without exposing those keys to any individual or company. At the same time, developers and users hold their own private keys, which means the network cannot decrypt their data or alter their applications. No cloud company, no foundation, not even the node operators have privileged access. If a government agency were to demand that someone unlock a user's data, there would be no centralized authority capable of doing so. This is a foundational difference between ICP and nearly all traditional systems. Switzerland's warning specifically called out the hidden supply chain issues involved in modern cloud architectures. Traditional cloud platforms depend on external routing systems, load balancers, indexing layers, third-party accelerators, virtual machines, and storage clusters. Each one of these components introduces another potential attack surface or legal risk. ICP removes these by running every layer, including routing, storage, and API-level functions, directly inside the network. There are no hidden indexing servers. There are no external databases. There are no secret control mechanisms. By design, the Internet computer creates an environment that addresses the exact vulnerabilities governments are becoming increasingly worried about. The global conversation around digital sovereignty is intensifying because nations now understand that digital infrastructure is directly tied to national security. In the past few years, cyber attacks have escalated into geopolitical tools. Countries have realized that relying on foreign companies for critical digital infrastructure puts them in a vulnerable position. Even corporations are beginning to recognize that placing their operational data into platforms controlled by a small number of global tech giants comes with long-term risks. And individuals are more aware than ever that privacy cannot exist when encryption keys are controlled by someone else. The truth is, the internet we use today was never designed to be sovereign or secure. It was designed for convenience and speed. As a result, nearly everything, from social platforms to national services to essential financial infrastructure, now depends on a handful of centralized systems. Those systems hold enormous power, and that power comes with major risks. This is why governments are shifting their focus. Instead of asking how to make cloud services faster or cheaper, they are asking how to build systems that are inherently resilient, transparent, and immune to legal overreach. Many countries are experimenting with national cloud platforms, hybrid systems, or local encryption layers on top of centralized services. But these approaches still depend on centralized infrastructure at the core. ICP takes a different path by embedding sovereignty into its architecture. It doesn't add encryption on top of cloud systems. It replaces the cloud system altogether by hosting the application directly within the decentralized network. Instead of trusting a company, the platform trusts cryptography and consensus across independent node operators. This brings us to an important philosophical point. Traditional systems ask, who do we trust to manage the keys? But ICP reframes the question entirely. Do we need to trust anyone at all? By distributing trust across cryptography, consensus, and independent hardware operators, ICP removes the need for privileged administrators or centralized entities. No one holds a master key. No one can be legally pressured to unlock your data. No one can unilaterally shut down your application. This is exactly the type of architecture regulators are beginning to push for, whether they mention ICP by name or not. The bigger message behind all of this is simple. The structure of digital systems determines the future of digital freedom. The infrastructure choices made today will shape the next generation of cybersecurity, governance, and user privacy. Switzerland's warning was not just a technical advisory. It was a signal that the world is waking up to a long-ignored vulnerability embedded in modern technology. Architecture matters, key ownership matters, jurisdiction matters, and dependence on foreign-controlled infrastructure matters. Whether or not ICP becomes the dominant global solution, the principles behind its design are aligning perfectly with what governments, institutions, and industries are beginning to demand. The debate over cloud versus decentralized infrastructure is not just a debate about technology. It is a debate about power, control, and sovereignty in the digital era. ICP is one of the few platforms built from the ground up to address the structural vulnerabilities now being recognized by regulators and cybersecurity experts worldwide. And understanding this helps us see the future shape of the internet. At the end of the day, control over your data comes down to one question: who owns the keys? Any system that does not give full control to the user will always carry legal, operational, and cybersecurity risks. The choices we make now will determine the level of freedom, privacy, and control available to us in the coming decade. Stay curious, keep learning, and continue asking who really holds the keys to the systems you rely on. So, what do you think about ICP's current position? Are you bullish on its growth in AI and DeFi? Drop your thoughts in the comments below. If you found value in this deep dive, don't forget to hit that like button and subscribe for more breakdowns like this. Thanks for watching. Stay curious, stay cautious, and I'll catch you in the next one.